Hello everybody, welcome back to another video of Tutor Bros, I guess. And this time it's going to be on Newton's third law, which is a law that's commonly misunderstood, mainly because of the definition that we use. And yeah, I'm going to be trying to clarify everything. So, sorry about not uploading previously. I hope you guys find this video helpful. So, Newton's third law states that every force has an equal and opposite reaction. And so let's imagine that we have a ball, and there's a force of 5 newtons to the right, and that ball is 1 kilogram. That's its mass. Well, force is equal to mass times acceleration. Well, net force. That's Newton's second law. So Newton's third law would kind of do it weird. So the force is 5 newtons, the mass is 1 kilogram, and then the acceleration would have to be 5 meters per second squared. However, Newton's third law states every force must have an equal and opposite reaction. So this force that I highlighted in blue here has to have an opposite force in the opposite direction of the same magnitude, 5 newtons. But why is the ball then moving? Why can the ball have an acceleration of 5 when the net force is 0? That's why this definition that most people use is very weird. Because if you can kind of find a loophole around it. So let's scroll down a bit. And let's try to find this out. We know that Newton's second law says net force is mass times acceleration. I'll correct that in a second, yeah. Mass times acceleration, which means if we divide through by mass, acceleration equals net force divided by mass. And there's no bad thing about that because mass can never be 0. And we've got the net force and the acceleration. That is why they don't have to be equal. That is why things can still move, because the masses and the sizes are different. So if we scroll down a bit, let's see. Let's say we have a table with a person on top of it, or let's say a floor with a person on top of it. That sounds more reasonable. And let's say the person is pushing down on the floor. Let's say 5 newtons, because we've been using 5 newtons so far. Well, then the floor has to give a normal force back up on the person of 5 newtons. That's what normal force is usually described as, like an opposite force, sort of. Well, same thing here. Let's just redo it, because I need more space. So at 5 newtons, then the table needs to push back up 5 newtons. That's the normal force. Yeah, there we go. Like I said, I'm recording this for a second time because my first audio recording didn't do well. So yeah, let's call that person A. Let's call that table B. Well then, the force of person A on, that's an M, not an N, on table B is 5 newtons, which is the third law partner force of the force of table B on person A. So that is a third law partner force. And as you can see, the A and the B is just switched. That's how you can find a third law partner force pair easily. So yeah, let's scroll down a bit and let's do another situation where there's a table, or not a table, like a vertical table, I guess, a wall. And let's say I pointed a gun at it and I shot it. The bullet would hit the wall, and let's say 50 newtons. I don't know if that's right, but whatever. The force of the gun on the wall, and the force of the wall on the gun would be the third law partner forces. Well, not the gun, the bullet, but yeah. So if the bullet had given the wall a force of 50 newtons, then the wall would push back with 50 newtons. And that's third law partner forces. Let's do another example where this time we have a horizontal table with a block. Yeah, let's say a block. And let's do a free body diagram on here, because that's what you should usually do for forces questions. You should always draw a free body diagram and then try to split it up into vertical and horizontal components and solve it like that. But let's save that for another video. So let's draw a free body diagram. We could do the force of gravity. That seems the easiest, probably. Yep, force of gravity, downwards. And the normal force of the table pushing back, upwards. So, let's label these. Waiting. Okay, yeah, force of gravity. Force of gravity. Yeah, force of gravity. We can also rewrite that as the force of the earth on the block. Because, that's essentially what it's doing. Gravity. It's given by Earth. Earth is doing it, and it's acting on the block. And then the normal force would be, sorry, I didn't label it. I'll label it later. The force of the table on the block. So, does that mean that these two are the third law partner forces? Not exactly. As previously stated, all you need to do for the third law partner force is just switch the letters. Switch force of Earth and block to force of block on Earth. Now, this might be a tiny bit funny because, well then, no matter how much we move, it doesn't seem as if we're changing the Earth's path at all. And the reason why is because the masses and the sizes are different. That's a really important thing. Just because this force is the same doesn't mean that the acceleration is the same. And that means that the result doesn't have to be the same either. So if I move 1 meter, then that doesn't mean the Earth has to move 1 meter either, because the masses are different. Just like in force equals mass times acceleration. The mass is different, so the acceleration has to be different. So yeah, the masses are just incomparable. So the third law of partner force of the normal force would be the force of the block on the table. So yeah, the block pushing down on the table. And yeah, that's the third law partner force of the force of gravity and the force of the normal force. That's the third law partner force. So if we have a force, don't call it force of gravity or something. Say the force acting on box B by box A. Call it like that, where A is the cause and B is the thing that's being acted on, the victim or something. And the third law partner force will always just be switching those two letters around. Hopefully you guys found this useful, but there's still one last thing I want to address, which is why the previous one is wrong. Why the force of the normal force is not the third law partner force of gravity. And if we do the same situation, normal force and gravity, the only relationship they have is net force is 0. That's it. Nothing else for them is special. Just because net force is 0 doesn't mean that they are third law partner forces. So we can do another example where we have a box on a table, but this time there are 3 forces. There's a diagonal force, a force to the left, and a force downwards. The net force is 0, but does that mean that those 3 are third law partner forces? Well, of course not, because third law partner forces only happen with 2 forces, and those 2 forces aren't even pointing in the same direction, so how are they going to be third law partner forces? So, just to recap, just because forces satisfy the second law does not mean that they have to satisfy the third law. So, yeah, that's why the normal force is not a third law partner force of gravity. Hopefully you guys found this useful. Sorry I haven't been recording. And if there's anything choppy, sorry I couldn't edit it off because I had to separately record the audio because the first audio didn't work out well and it just was completely muted. If you guys like this video, consider liking and subscribing. If you guys want to, it just helps us make these videos. And hopefully you guys enjoyed this video, and I'll be signing off. Bye.